So today we're gonna review some exponent laws. I don't know if you guys did this in grade 11, but probably from some previous courses you might recognize some of this. So first let's just talk about the components if you're working with exponents. So the whole thing, if you see a base raised to an exponent, is called a power. The main number that's below the exponent is called the base, and then the small number is called the exponent. You probably know most of that already. These are exponent rules, so we're going to apply these in the questions below. So when you're multiplying two things with like bases, you keep the base and add the exponents. When you have an exponent on an exponent, keep the base and multiply the exponents. For dividing powers, dividing two like bases, you'll do keep the base and subtract the exponents, top minus bottom. Do you remember this? Okay. Excuse me. And then anything to the exponent 0 always equals 1. And then for negative exponents, whenever we are expressing things properly, mathematically speaking, we will never express something with a negative exponent in the final answer. So you simply just change the side of the fraction that it's on. So right now, this is considered to be in a numerator. Even though we don't see a denominator, we know the denominator is 1 technically. So to make the exponent positive, you would move this down into the denominator. Okay, and then vice versa. If you see it in the denominator, you can move it up into the numerator and make the exponent positive. Okay, so in all questions, we're going to aim to express things only with positive exponents. All right, so we're going to apply them as we go through here. I'm going to try to regain my voice. Okay, so one important thing to note as well is if you're multiplying things with unlike bases, you cannot apply the exponent rules. So it has to be x and x, or 2 and 2, or 3 and 3, or whatever. Otherwise, you don't put them together. Okay? All right, so for this one, we're multiplying two like bases. So what exponent rule are you going to use? Which one looks like a similar format? Do you have an exponent of 0 though? What's the operation with the bases? Or what's the operation happening? Okay, so we'll use the multiplying powers one then. Okay, so multiplying powers says that we will keep the base as is and add the exponents. So I'm going to keep the 3. And then we'll express the exponent 5 and the exponent 3 as an addition. So 5 plus 3. Okay, and then we'll have 3 to the exponent 8. And if possible, we'll use our our mind to evaluate, but this one's kind of hard to evaluate 3 to the 8, so we can use our calculator for this one. Yep, 6,561. Perfect. Okay, so for B, we're multiplying again. So we'll use the multiplying powers rule. So we're going to keep the base and again add the exponent. So it'll be -2 plus 5. So simplify those exponents to 3. $125. Okay, what would we use for the next one? 3 to the 5 divided by 3 to the 2. Yep, so any idea how this would condense into 1? Yep, so that's that rule right there, right? So it'll be the first one minus the second one, so 5 minus 2. Do you know what 3 to the 3 is without using your calculator? So 3 times 3 is 9, times 3 again. 9 times 3. Close. One more 9. 27. Okay. This is also division, right? When you have something over something, that's another way that this can be written. So we'll do the same thing. We'll keep the base, which is 5, and subtract the exponents. One thing to note is that we already have a -1 here, so it's going to be like minus -1. I'm going to write that in brackets. Oh, did you simplify to plus right away? Yeah, you could do that. Okay, so it'll be like 5 to the exponent 3 plus 1, so 5 to the 4. What'd you get? 625, perfect. Okay, what would we do for E? What rule does this look like to you? Multiplying the exponents? So is it 2 different bases being multiplied though? So it's more in this format, right, where it's the power of a power. So what should we do with the exponents then? Yeah, okay, perfect. So power rule, keep the base, do 3 times 4, we'll get 2 to the 12. 4096, perfect. Okay, and then how about F? What rule? So we'll do 3 times 2 when we do power rule. That'll give us -2 to the 6. One important thing here is it probably depends on the calculator, but you might have to put brackets around the -2. But let's just see what your calculator does. Yeah, so you need brackets. So if you were to just enter this, just for the purposes of the video, if you were to just enter this without exponents, it actually doesn't include the negative in the exponent. So of course, anything to an even, anything that gets multiplied by itself an even number of times should actually give you a positive, right? So what did you get here? Yeah, so it should be positive 64. So just pay attention to that as you're calculating negatives. Okay, let's get into a few more here. So when you have a fraction, what you're going to do is you're going to apply that exponent onto the numerator and onto the denominator of the fraction. So it's basically going to be like 1 squared over 3 squared. Actually, I put the squared inside the bracket and outside, like 3 squared squared. So I'm applying this to both the top and the bottom. And then we can just simplify the top and simplify the bottom. So what is 1 squared? 1. And then what do we do when we have a power on a power? Yep, so we'll multiply the exponents here. So we'll get 3 to the 4. And then we can just evaluate 3 to the 4. And we'll leave it in fraction form. What'd you get? Yep, perfect. So 1 over 81. Okay. Let's look at h. So 7 to the exponent 0. Yep, anything to the exponent 0 is 1. So -32 to the 0. No. No. What's anything to the exponent 0? 1. And then let's look at the negative exponent rule here. So if I have 1 over 4 to the negative 2, we talked about how you can take that denominator, and if you move the base and the exponent up to the numerator, you can actually make the exponent positive. So this is equal to 4 to the positive 2, and then we can evaluate from there. So what's 4 squared? No, 4 times 4. So 16. Okay, and then this one right now is in a numerator. When we look at 7 to the negative 2, so the way that we make that positive is we move it down into the denominator. And I will keep the base and just change the sign of the exponent. So make it positive. What's left in the numerator? 1. So 1 over 7 squared. And again, we'll leave this in fraction form. Yeah, so 1 over 49. Perfect. Okay, and then what exponent rule are we using for L? Okay, so keep the base and multiply, or sorry, you add the exponents if you're multiplying like bases. So if I'm raising this to an odd exponent, would I expect to get a positive answer or a negative answer if I multiply a negative? So if I multiply a negative by itself an even number of times, that will give me out a positive. But if I do negative times negative, that gives me positive. And then another negative times another negative, that gives me positive. Then I multiply it by negative one more time. That's going to make everything negative. So if you have an odd exponent, you should expect a negative to give you back out a negative. But I want you to also write brackets in here just so you get used to. Did you do negative 4 or negative 5 to the 5? Yep, good. Negative 1024. All right, so we can do this with numbers, but we can also do it with variables as well. So the goal is anytime you have an expression that has variables, it's fully simplified when all like variables are gathered together. So like all the A's are gathered together as a single A, all the B's, all the X's, whatever you have. And then we'll also try to follow BEDMAS too. So if there's exponents, we'll do that first, and then divisions, and then all of that kind of stuff. Okay, so for these ones, what's the operation happening between these two brackets here? Okay, so what should we do with the like bases and their exponents? So how will I put the exponents for A and B together if their bases are being multiplied? Yep. Okay, so we'll have A to the negative 2 plus 3. What's the exponent on this B in the first bracket? Yeah, so if we don't see it, we know it's a 1. So it'll be B to the what? Well, and then combining it with this one. 1 plus 4, right? Because the exponent of B is 4. Okay, and then we'll simplify. So we'll get A to the exponent 1. I'm just going to write A because we don't write exponent of 1.
We don't need to write exponent of 1. And then what did you get for the B? Yeah, perfect. Okay, and then this question tells us A equals 1, B equals negative 2, and C equals 3, and it wants us to evaluate after we've simplified. So we're just going to plug those values in for A and B. This one doesn't have a C, so have 1 and then -2 to the 5. Okay, one important thing here that we make note of is that exponents have to happen before multiplication, right? So we'll do 2 to the 5 or -2 to the 5 first, and then we can multiply. So what do we get for -2 to the 5? Right? And then what's -32 times 1? You're not doing that in calculator. Okay. You're gonna be in trouble there for a second. Alright. Let's do B. So, goal is all A's need to be gathered, all B's and all C's, and no negative. So, if we're dividing all of the like pieces, we do with their exponents. So, a to the -4 minus 1, because this one has an exponent of 1. C also has an exponent of 1 on the bottom. And then B, 5 minus 3. So we've top minus bottom, right? And then C, 2 minus 1. So we'll get A to the -5, B squared, and then C will just be to the exponent 1, but we're not going to write that. And then I also need to make sure that I don't express any negative exponents. So what do I need to do with a to the -5 to make it positive? Before we do any plugging in, I want to make the exponent positive on the a. So think about what we did here above with the negative exponents. Okay, so we're just gonna switch the side of the fraction that it's on. So right now it's in the numerator. We're gonna bring it down below the b squared and the c, and then we can make it positive. So we'll get b squared c over a to the positive 5. Okay, so I think we have the goal. All B's are gathered, all C's, all A's, and there's no negative exponent. Now we can sub in for what it says each of them are equal to. So 1, -2, and 3. So let's do the subbing in. B is -2. C is 3, A is 1, so -2 squared, four. What's 1 to the exponent 5? No, 1 times itself 5 times. Yeah. And we're making sure we follow BEDMAS, right? That's why I did the exponents first. And then we can do 4 times 3, which gives us 12 over 1. And what's 12 over 1? 12. So far, so good. Okay, so you have two values inside the bracket now, and they're being cubed, and so it's essentially like exponents to an exponent, or power of a power. So what are the rules? Which one should we use? Yep. So keep the base, multiply the exponents. So we have to do that with the A and also with the, so it's gonna be A and then 5 times 3 as the exponent, and then B 2 times 3. Both of them are in the bracket as part of that, right? Okay, so we'll get A to the 15 and B to the 6. These are multiplying the A and B, but we don't gather those together, right? Because they have different bases. So we're just looking at how we can simplify the A and the B to this power of 3. Okay, then we can sub in our values. So 1 to the 15 and negative 2 to the 6. What's 1 to the exponent 15? 1 and negative 2 to the 6. No, so that's to the exponent 6, right? Not times 6. 64. And then we have 1 times 64. So obviously just 64 there. Okay, great. Okay, and then this one's similar, so we have to, we already have all like bases gathered, but we have to simplify this power of 5. When you have a coefficient, and what I mean by that is like a number in front of your variables. So the 2 is a coefficient here. We have to apply this exponent to each thing inside the bracket. So not only the A and the B, but also to the 2. Because this whole thing is going to be multiplied by itself 5 times. So the 2 will also be multiplied by itself 5 times. So right now the 2 has an exponent of 1 and the B has an exponent of 1. And we're going to use power rule for all of them. So it'll be 2 to the exponent 1 times 5, A to the exponent 2 times 5, and B to the exponent 1 times 5. So that just gives us 2 to the 5, A to the 10, and B to the 5. And to fully simplify this expression, like before we sub in, we usually will evaluate any coefficients with their with their exponents. So what is 2 to the 5? Okay, 32. So this would be the fully simplified form of this expression. And then if you're given what A and B are equal to, then you can sub in from. But anything that can be evaluated that's already in the expression should be evaluated first. Okay, so let's sub in then. We know that A is 1 and B is -2 in this question. Okay, so following bedmass here, we do exponents first. So 1 to the 10 is 1, and -2 to the 5. Well, 2 to the 5 is 32. So what's -2 to the 5? Yeah, -32. Okay, and then we'll multiply all of those together. Good. -1020. Okay, and then we'll do an application. So the number of hybrid vehicles sold in the United States, which is represented by S, can be modeled by the formula S equals 199,148 times 2.39 to the exponent n, where n is the number of years since 2005. Evaluate the formula for n equals 0. What does this formula represent? Okay, so we're going to sub in n equals 0 into the formula. Okay, and bed mass is important here again, so we do exponents first, which means I'm going to do the 2.39 to the exponent 0 first before I multiply the 199. So what's anything to the exponent 0? No? 1. Okay, so that ends up being 1. And then what's 199 2,140. Yeah, just itself. Get that back. Okay, so S represents the number of hybrid vehicles sold since 2005. So if and N is the number of years since 2005. So what did we just calculate and what did we just find? So N is 0, so that's 0 years since 2000. What's 0 years since 2005? What year is it? 2005. So what did we figure out then? Perfect. Okay, so therefore there were 199,148 hybrid vehicles sold in 2000. If it's 0 years since 2005, then of course that means we're finding when, how many vehicles were produced in 2005. Oh, not since in 2005. And I should put produced here. Okay, estimate the number of hybrid vehicles sold in 2004. So if 2005 is 0, what's 2006? If it's N years since 2005. 1, and then 2000. Okay, good. So -1. So we'll say N equals -1 here. Estimate. And we're just gonna plug this all into our calculator just to avoid any rounding issues or anything like that. So exactly as shown. Right. Sorry, I put produced here. I should have put sold. Yeah, so it would be 0.5, but of course we can't sell half a car, so then we have to round down in that case, right? So we're gonna do therefore there were 83,325 hybrid vehicles sold in 2004 based on the formula. That would be our estimate. Okay. And then predict the number of hybrid vehicles that will be sold in 2007. So what should we do for that? Yeah, yeah, perfect. So that's 2 years after 2005. So we'll put in 2 for N. And if we enter this into our calculator exactly as shown, it will take care of bed mass rules for us. But just make sure you're never doing this times this first. We want to do exponents first. What'd you get? Mhm. Yeah, perfect. And technically it's like 0.29, but of course, again, we know that we can't sell 0.3 of a vehicle. So what would you say for your therefore sentence? Mhm. Great, that's it.